let's take a look at mapdemo.java. This is the class where we're going to explore maps and these four particular methods. We're going to try to keep this pretty simple as we go. All right, so a couple things first. The map interface. So the map is an interface. It's not a class. The map interface is a generic. Unlike array list, unlike linked list, unlike set, um, there are two types in the map interface generic: the type of the key and the type of the value. So the first type is the type of the key, and the second is the type of the value. Let me show you what that looks like. So I want to create the type of my variable will be a map. Again, the types of our variable, we try to use the most generic class possible. So I'm going to use my type of my variable is going to be of type map, not hash map, just like the type of my variable when we were doing sets was of type set and not hash set or tree set. So we're going to create a map from names, your names, to your favorite color. So the key is going to be the string that is your name, and the value is going to be a Java color object. And I'm going to call this variable favorite colors. And then I'm going to create a new hash map. And I'm using the shortcut here where I don't need to re-specify string and color. It's implied by the type of the variable I'm assigning it to. So that saves me some typing. I still do need the angle brackets to specify I do appreciate it's a generic. And then I'm calling the default constructor. So that will make a new empty hash map. Nothing's in it. All right, so let's see what the put method looks like. So I'm going to say favorite colors dot put. Jason, what's your favorite color? Orange? Color dot orange. There we go. Let's do some more examples. Luke, how about you? Blue? So we'll add in that one. Let's do one more. Christian, how about you? What color? Purple. Ooh, let's see. Purple might be problematic. Purple's not a Java standard color. What's your second favorite color? Why is that? Why isn't purple in the Java standard library? Isn't that weird? Oh, I wonder if it's called violet. Nope. I don't know. Second favorite color? Green. Okay. Someone should file a bug request with Oracle. Feature request. All right. Here's the thing. Two different keys can have the same value. Anyone else have a favorite color of blue? All right. I saw Kevin raise his hand first. So we can say favorite colors dot put Kevin color dot blue. That's fine. Just like with our textbooks, two different barcodes can refer to the same type of textbook, even though they're not the same physical textbook. Luke and Kevin can have the same color and refer to the same Java color object. That's totally fine. However, but the same key cannot have two different values. Instead, we change the value associated with an existing key. Cannot spell associated with an existing key. So favorite colors dot put. So Jason, you've had a change of heart. What's your new favorite color? Blue as well. Excellent. Cool. So again, what this does is there was an association between the string Jason and the color orange. When we call put again, we don't get an error. There's no exception. we simply reassociate the key JSON with the color blue now. There's no longer an association to the color orange. Let's take a look at the key set method, because this is a super common way when we need to. I'm not going to show you how to necessarily, well, I am, but if we get things, it's very straightforward, but iterating through is a little bit different. So here's how we iterate through all of the elements in a map by key. Retrieve the set of keys in the map. And so the type of the key is a string. So this is going to return a reference to a set of strings. These are my keys. And I do that by saying favorite colors dot key set. Now I have a reference to a set, just like we've had before. And I'm going to iterate through all the elements of that set, just like we've done in the past with sets. Question for you all. When I write code like this for string key in keys, given this code and given our keys, in what order will we be iterating through these keys? Think about it for 20 seconds on your own. All right, discuss with your neighbor, what do you think will be the order that we iterate through these keys? What do we think? What order are we going to iterate through these keys? Any ideas? You said first in, last out. We will study a data structure like that later this week. That's like a stack. That's, I think maybe that's what you're thinking of. That is how a stack behaves, but that's not how our map will behave. Yeah, it's going to be some random, but deterministic, but we just don't know what it is. Some random order, right? I think I overheard some pairs talking about like alphabetical order. Um, if we wanted to iterate through our map where the keys were in alphabetical order, what would we have to change in this code to make that happen? We'd have to change like one word. That's exactly what we do. Yes. If we made this a tree, well, a tree set and therefore a tree map, if we made this a tree map, the keys would be actually a tree set. And therefore, when we iterate through them, they would be in sorted order, lexicographic, alphabetical, more or less order. But these will be seemingly random. But let me show you something cool about how it's not really random. It's just hard to predict. So if I say system.out.println, let's print information about each value in our map. So I want to print the key itself. That'll be like the string, the name. To that, I'm going to concatenate, and I'm going to put in parentheses key.hashcode. Okay. So hash code is a method that's on the capital O object. You may remember that from the past, like other methods like equals. But this will return the hash code. So I'll make this look kind of formatted nice. And then I'll concatenate favorite colors dot get. So here I'm invoking the get method and I specify the key. There we are. So for each value in our map, we're going to print the key. In parentheses, we'll have the key's hash code, and then we'll have the value associated with it. So finish typing this, run this, look at the output and see what you notice. This is like a notice and wonder thing. Look at the output, see what you notice, see what you wonder about the output of this code. So I wanted to print the hash codes because I want to perhaps inspire you to look more into the extensions we had on the previous Canvas page with our sets about hash sets. These are the hash codes. These are the integer values that are derived from these strings. Okay. So in those extension resources, it talks about a hashing function, meaning how do you take an object like a string and turn it into a 32-bit number, right? And how you do that in a way that chances are multiple different strings won't be hashed to the same number. Okay. But of course, it's possible that multiple different strings would be hashed to the same number. It's just we want to make that unlikely. We can never make it impossible because there's certainly more than 4 billion strings out there. Um, so these are the hashed values of these corresponding strings. Okay. Are these in like any sort of order? They're not, right? So it's not like we simply sort by like the hash values. These hash values are then used to figure out where in our hash map we actually store um, the associated values. But we don't just do it numerically because if you think about it, there's 4 billion different numbers we could have here. And if we wanted to use those numbers as like indices into an array, we would need an array with 4 billion elements in it. And that's like a lot of memory, right? Like we're not going to do that to keep track of your favorite colors. I mean, I'm glad you have favorite colors, but we're not going to spend 4 gigs on that. Um, so something else has to happen, right? And so different approaches that are taken is how do we, given the hash code, how do we determine which bucket in the hash set we put the thing in, right? And the way we do that varies. There's different algorithms, but maybe we just look at, here's a simple example. Maybe there's only, and to be clear, that's not how this is working. Let's say we only have 10 elements in our array, okay? So maybe all we look at is the last digit, and we use that last digit as the index into an array to store these things, okay? That's not the approach being used here because that's not the order we have, but that's like would be a simple example of how this works. So what's cool about all of this is because we're using like the hash set as part of our hash map, the time to get an element out of a map is order 1 again, right? Crazy fast. And the time to put a value into our map, also order 1, okay? And the time to remove it, also order 1. All of these are super, super fast. If we use a tree map, again, it's slower, just like a tree set is slower. We're now on order log n, okay? But that's still pretty fast. So yeah, so if you're curious, hit the previous section link on our page. It'll take you back to a sets page. At the bottom of that are extension resources, and you can learn all sorts of cool stuff about maps. I'm sorry, about hash sets and hashing and all those things. So, all right.